Welcome to the next part of the series, First Steps in Facade Construction. In the first steps, we created the facade, modified it, added consoles and connections, and also transferred changes to the logic. Furthermore, we then generated the email facade. I attempted to create sections, which means I set up the first sections with detail views that are, of course, still far from finished. This was just to show how this works. In this video, I would like to present the next sections, create detail views, and try to complete them as much as possible. And here, again, to use various construction techniques, I have these detail views here in Helios. I specifically want to go to this tab where only my detail views, overview drawings, assembly plans, and section drawings are displayed. I will start with detail 2, which I will open here, and I really want to create the next detail from this one that needs revision, focusing on precisely the area of floor connection. To accomplish this task effectively, I will save this file again with a new name. It shall be called Detail 03 Floor Connection. Additionally, I'll also select an option for detailed drawing purposes. By clicking OK now, this drawing gets saved once more, and then I'll change its name so as to find it more easily through article stem identification. Now then, what remains is changing up how we view these details. No upper areas anymore, but rather lower ones instead as our focus point. And yes, indeed, changing names too. At present moment though, this particular detail has been pulled down within hierarchy levels already. Henceforth, all that's left involves dragging and dropping back upwards, thereby modifying said details anew accordingly. In previous videos lately, however, I've always created such intricate detailing either via three-dimensional means or alternatively inside plate areas. There is only one difference between the plate and model areas. This means that when drawing sheets in section, it is somewhat more difficult to make changes in the plate area. I would like to demonstrate this right away. That means I will essentially draw the first sheet at the back here. I would just like to draw a sheet, a closure sheet, right over here at this point. In this case, I would also like to include an HCM dimension. Now I create a sheet from this sketch, generating it with the respective properties. The length is irrelevant here. It only concerns this section. The difference is that if I click on the sheet in this area and then go to the feature, I do not see these dimensions. I have temporarily adjusted this view. I rotate it back to the correct position and lock this view at the same time, so that I cannot accidentally rotate this view again. This means that if I rotate now, this view will jump back to its original position. But what I wanted to address is that when I click here, it is very common to see these measurements. That's why I really like using this detail in my model. I temporarily pull and do the same in the model, which means that if I click on this sheet again, I will immediately see these measurements and can change them much more easily. And when I am completely finished at the end, I can simply pull this back into the sheet and it will be in the same place again. This means I will still keep this detail in the model and continue to work on the model. I am using the option again that only the active view is displayed, so that means I have my first sheet here. I would naturally like to pull this finish forward here. This means that I can actually use this again in this case, that I am directly in the 3D model here. In this floor, I can add this or supplement it in the cut here. Of course, I can use this option where I can draw a line directly in the cut. I can then define this line with various values, meaning I can store different values. Here, for example, I have stored a tile here. And with the medium load, this tile is also immediately integrated. To complete this finish, I would like to incorporate a ceiling with a light cord here. And I simply specify the edges of the respective boundary edges here, thus achieving my ceiling. Furthermore, I would like to seal this area with a film. That means I can go here in my area, use film, and draw the contour of my film. Here, I naturally have a variety of options to use films from various manufacturers. Here, one thing must be noted. It can be seen that a width of 24.8 millimeters would be required. That means if I were to deliberately take a film that is only 200 millimeter long, the side cut would not incorporate it here because this film is too short in width. Of course, I can definitely also define my own films in various areas here. And you can immediately see in the preview that this film is there, so the film can be installed. Of course, I can also define individual areas of the film here with the right mouse button, modify them, and incorporate them in a different direction. With OK, this film will also be installed here. Afterwards, I would also like to graphically indicate that insulation or a screed should be added in this area. This means that I could naturally draw various areas here, and in this case I can again use my own definitions or the existing ones to properly represent the structure. This implies that I have the ability to naturally delineate a variety of different areas in this context. And in this particular scenario, I am able to once again utilize either my own definitions or the pre-existing ones to accurately and properly represent the overall structure. Because I want to incorporate insulation here, I will temporarily add a ceiling, which I will then delete again to ensure that this area is closed. Since I am aiming to incorporate insulation in this specific area, I will temporarily add a ceiling layer, which I will subsequently remove to ensure that this particular area is completely and effectively closed off. I can work with the insulation here, then with the middle mouse button, I can cancel this area and look for a point here. Since this area has now been closed, because I do not want to carry the insulation into this area, I will create my insulation here. This means I can choose again from a half cut. In this case, I can also make this transparent if I want to, or not. I can easily do this later as well. So, I have my internal connection basically finished here. I would like to create a visualization, which means in this case, I want to select a screw from my screw library. This means I first need to define a layer, which I will do by right-clicking vertically to the screen plane. I want to ensure that the blue arrow indicates that the Z-axis is pointing down towards me, where the head will also be. I will create this layer and then select my screws from my screw library. I deliberately choose a slightly longer screw here to demonstrate this. That means I have incorporated this screw in this case, and I can of course edit it at any time with the right mouse button and change it to another screw from a different standard or with a different head. I can modify all of this at any time afterwards. However, in this case, I just want to take a shorter screw. One can see here, again, that this detail is repeatedly crossed out. As I mentioned in the previous videos, I am simply focused on the screw guide here. That means I have assigned it to the X key. In this case, it would be this command again to simply make this faster. So don't be surprised if I keep pressing this button. So, next I would like to have a foil guide plate at the front, which means I want to screw or anchor a sheet metal to the bottom here, again selecting my material, choosing the length and selecting the material, and with OK, this sheet metal is installed here. In this case, if I have placed the sketch incorrectly, I can simply go ahead and move this sheet metal here at this point. Of course, I can also have my second sheet metal here, meaning I would like to have a sheet metal that is screwed to the bolt. I like to add the dimensions to the sketch as well to make it easier to modify later or to know what I have drawn there. In this case, I simply copy this screw, and I have this screw here as well. Of course, I want to screw this in at the front, which means I go back to my screw library, right-click perpendicular to the screen plane, and I have to pay attention to ensure it's a Z-axis. I can now insert my next screw. No, that's not the one I wanted. So, I can also work with various point options here, for example Dora, and set the value to 20, indicating from this edge. This means that this screw has now been placed 20 mm on from this point. I can of course change this at any time if I say I only want it to be 10. Then I can again create my sheets here, meaning I can come here and say that I want a sheet. This sheet should be installed. I can turn off point options so it is easier to install. And here we select another sheet, which should be carefully revealed inward. Furthermore, I can, of course, seamlessly incorporate my own purchased parts from a catalog, just like before, with the same option to place my screws myself, making it extremely easy to install them in the last step. In the final step, or the last step in this area, I would like to have adequate insulation, which means I go back, press the mouse button, select my option, and say it should be filled with insulation, and ensure it is properly done. I click here for the contour search. Here, my contour search will show what should be filled. In this case, I consciously say completely transparent because I want to leave it out in the first step so that it looks the same. Transparent means that in this case it would cover the other screws and everything behind it, which I do not want. So I click again, double click, and say, in this case it should be completely transparent, meaning that the rear parts will also be displayed. In the last step, I still want to add the flooring outside, which means I will again select a command. Wait, that was the wrong one. So I provide a sketch of where it should be and want to use what I have carefully stored in my organized catalog. Now I have to think about where I stored it. For example, I have stored paving stones, and I want to incorporate these here as well. Now I will just adjust to the right height. The last point I want to make here is to add a small panel, which means I will again use the same functions, meaning I want to create a sketch here. This sketch is supposed to be placed inside here, should naturally be aligned with the glass plane, and should have a certain inset. And of course, a certain length is sufficient in this case, and I have totally used the right mouse button along the sketch on the first page, which involves carefully clicking and dragging to ensure precision, and thus I have the first sheet metal. This sheet metal is crucial because it forms the base structure, and I will also copy it back later to ensure consistency and accuracy in the design. Now, I would like to incorporate a plastic part here, which is essential for providing flexibility and durability, and I want to copy it downwards to maintain alignment with the overall design. Additionally, of course, there should also be insulation added in this direction, which is vital for thermal regulation and soundproofing, ensuring that the final product meets all necessary standards and requirements. So in this case, I have selected a soft insulation, which is a type of material used to prevent heat loss or gain, with a thickness of 50 millimeters. This specific thickness is chosen based on the requirements of the project, and you can see in the preview that this thickness is either too low or too high, depending on the specific needs of the insulation. This means I can still adjust it and modify the insulation to better suit the project requirements. Now I have essentially finished these areas, and I will drag this detail into my sheet, which is a document where I organize all my project details and want to label these items as well for better identification and organization. Thus, I can go ahead and define my important height, dimensions that are significant for me, ensuring that all measurements are accurate and meet the project specifications. Of course, I can also add text at any time. My last texts will be displayed here for easy reference. For example, I can also dimension my various measurements at any time, ensuring that all dimensions are clearly marked and easy to understand. I also have the option to set my designations, meaning I have predefined designations that I can define, which helps in maintaining consistency and clarity throughout the project documentation. That was obviously wrong. That means I will literally switch to manual here. Here I can see my predefined designations. That means, for example, here I have the item number plus the designation, item number, remark, and material number. That means I can define these designations generally. I also have designations for details here, and since the parts always know what they are, I can easily label the parts in a normal way. So, of course, everyone can label in different ways depending on what I want and preferences. In this case, I can always access the parts here and choose what I want and options. The last step, that is important for me, which I actually left out completely, is that I have modeled the items here. I haven't made sure that they are arranged neatly and carefully. That would be done later. I am aware that there are still far too few dimensions here. One can imagine how to build this detail further. However, what is important here is that I have simply modeled this area without paying attention and quickly created the part. This part is only visible in this detail. But I would like, of course, that if I have more details, these parts are also visible in the other parts and comprehensively. That means, for this reason, I will also pull these parts that I have integrated here into the external references so that they also appear in other constructions. The assembly structure, of course, should not be underestimated, but especially at the beginning, when one does not yet know what is needed, this is naturally difficult. As an example, it would of course be easier to say right here that this should be my assembly. And of course, accordingly, a method of use that I will need for the subsequent workshop drawings. Thus, I have at least one detail, somewhat finished here, which can certainly be further optimized. I am aware of that. In this particular case, I can also add the views with dashed lines and include my dimensions and everything else in the view, as well as add a 3D detail. I will quickly do that now so that it is easy to see. I will just copy this detail so that one can also see that everything is happening in 3D. This means we will make it a bit smaller, and since the division is still locked, I would like to rotate it here so that one can see. This means I have drawn everything completely in 3D. I would, of course, delete the labels that came along with this detail. So now I have a 2D and a 3D part. And through referencing, I would immediately have a PDF. If I now go back to the overall model, everything will be updated here. And you can also see that all the parts I modeled in detail are also present in the 3D model. Therefore, I actually do not need to pay attention to the lengths here. I would just leave them as they are until I have approval, and only then bring them to the correct lengths. In conclusion, this approach ensures that all elements are accurately represented in both 2D and 3D formats, providing a comprehensive view of the model.